The next step after proper sampling and homogenization in the analytical scheme for determination of mycotoxins is extraction, filtration, and cleanup. And that is what I will dwell on in the next 15 minutes or so, I guess. Let's talk about extraction first. So you've seen in my previous presentation that the mycotoxins which are around cover a wide range of chemical properties, polar to apolar, and they can certainly not easily be extracted with one single extraction solvent properly, and that is why within our effort to accommodate as many toxic secondary metabolites and ideally also accommodating all relevant mycotoxins within one single analytical method, a major optimization step was actually finding the proper extraction solvent. And when you see here representatives for HT2 toxin and zearalenone as more apolar ones, and nivalenol as a polar one, formonicin as an acidic polar one, we see here on the y-axis the extraction efficiency in percent, and in blue the results, the recovery obtained when extracting with methanol water. And well, not surprisingly, for the highly polar nivalenol, actually that can be quite well extracted with methanol water. However, for the less polar zearalenone or ergocornin, an ergot alkaloid, the recovery is actually very poor. Too poor, because when you're something like 5 to 7%, that is non-acceptable. What is actually the reason why we want to have a reasonable high recovery? A lower recovery certainly potentially limits the sensitivity, the limit of detection of your method. But more importantly, lower recovery usually yields in a lack of precision of your method as well. So one can summarize, at such a low recovery rate, the method is not under control. So moving on to acetonitrile water, 84 plus 16 in ratio, results displayed in red. Actually, quite a fine extraction solvent, suitable. However, for formonicin B2, we again have an extraction efficacy of only about 10%. So, well, this short story, which I kind of tell you in a couple of minutes, was actually an undertaking of a couple of months. Yeah, so that has also to be pointed out at this point. By adding acetic acid to acetonitrile water, we actually, in green, could still achieve reasonable recovery, but for formonicin B2, still not a fantastic recovery, but it's getting there. It's actually, it can be, under these circumstances of actually having to find a compromise, be considered as something like a reasonable recovery. So best compromise for multitoxin approach, in this case for wheat, low water content, low pH, and in this range of acetonitrile water, acetic acid, 7921. Well, once extraction was performed successfully, and in case you are not pursuing a multi-analyte, a multi-toxin approach to cover ideally a couple of hundreds of metabolites, a way forward to get rid of matrix interferences on the one hand, but also to purify, to get higher concentrations of your analyte. On the other hand is solid phase extraction. So what you have got actually is, for instance, a polyethylene cartridge with solid phase extraction material that can be alumina oxide, can be silica, C18 or C8 modified silica to make it more apolar. So you perform the conditioning, Then you add your sample extract, which contains a couple of interfering components, but in red, also your mycotoxins of interest. Then you perform a rinsing step where you add a solvent which is able to remove the matrix from the solid phase extraction material. So this solvent has obviously a higher affinity for these interfering components. That is why they are eluting into the mobile phase, but are not sufficiently affine towards the mycotoxins. So that is why the mycotoxins will still stick and remain there at the column. And the final step, you perform an elution with, for instance, pure acetonitrile, or could be pure water in order to elute nivalenol, and you get your analyte. Two advantages. One, you can actually get rid of interfering matrix components. Second one, you can actually purify, enrich the compound of interest, enrich your mycotoxin, because when you add a 100 milliliter of your extract and then you elute with 1 milliliter, you have an enrichment factor over 100. But you can use the solid phase extraction column in different modes, right? You can also play it the way that you don't elute, but you add your sample, your matrix remains on the cartridge, and your analyte, your mycotoxin, goes through the column right away. There are different ways and different strategies. Nowadays, actually, polymer-based columns, even integrated in 96 well plates, are on the market, which have already got an integrated solid phase extraction material. Well, this is a method, a cleanup method, which is quite well known on this campus, because it's sold by Roma Labs. They have developed this so-called Mycosep column. So you've got a culture tube, here a maize extract containing your matrix components, but also your mycotoxin of interest in red. Then you have got a column. This plastic column is filled again with a mixture actually of different packaging materials, adsorbents, charcoal, phthalates, ion exchange resins, and so forth. And then you push that column into this culture tube, and it actually is cultured into this culture tube, and this column which you push into the culture tube has a one-way valve here, and your extract will be pushed through this one-way valve, and at the top of the column, the purified extract appears, and then actually you can pipette the purified extract, ideally containing only the mycotoxin of interest, can be ejected in the column. Or in the column of the HPLC or LCMS method. Rapid extraction in less than half a minute. Removal of the matrix, however, mainly restricted to trichothecene, and no enrichment, because you just push through, and you've got the same concentration of the mycotoxin in this tube as at the top of the column. That is why. To increase the specificity, or more precisely the selectivity of the column, in combination with purification and enrichment of the component, immunoaffinity columns have been developed. You have again these plastic housing in which, in this case, saccharose, agarose is immobilized. Containing a couple of a couple of antibodies which are specific for certain mycotoxins. So these are, for instance, specific aflatoxin antibodies. You first perform a preconditioning of this column in kind of to make the antibodies active again, so that they can rearrange themselves into the solvent. Then you add your sample extract, which contains matrix components here in blue, and in red your mycotoxin of interest. Then you perform a rinsing and a drying step, so you get rid of all the matrix components which are still in the solution, somewhere dissolved in your column, and only the mycotoxins, because of their specific affinity to the anti-mycotoxin antibodies will remain on the column, and finally, usually by addition of a pure organic solvent, as for instance acetonitrile, you kind of kill the antibody to kill its three-dimensional structure. It releases the mycotoxin again, and actually and you can find it in the elution solvent. Whether this is always needed to use pure organic solvent, that is to be discussed, that is to be found out for the individual column. If you would like to save costs, actually you can find conditions which are organic enough in order to elute the analyte so that the antibody releases the mycotoxins but does not kill the antibody. So that is the ideal case. If you would like to be on the safe side, well, then use pure acetonitrile. So several immunoaffinity columns have been developed for deoxynivalenol, zearalenone, aflatoxins, OTA, fumonisins, have also been validated in European collaborative trials. And actually, just a couple of years ago, the so-called 6-in-1 column, there are actually 6 mycotoxin-specific antibodies immobilized in one single immunoaffinity column, has been developed. Pretty expensive, I think 200 euro plus, but that has to be decided for your particular analytical task whether this is worth the investment or not. This shows actually the power of an immunoaffinity column. So you see actually here between 2.5 minutes and 7 minutes, there's actually just one peak, although this is a maze matrix where actually zearalenone elutes, and actually that shows that this is a really selective method in combination with liquid chromatography and fluorescence detection after immunoaffinity cleanup with a reasonable uncertainty of 6% and an LOD of 3 microgram per kilogram. So that is just to demonstrate that these methods actually work pretty well. So once you have forgotten about all the things you learned at the Mycotoxin Summer Academy, you can always go back to your script and just find a summary of the major advantages and drawbacks of major cleanup methods for mycotoxins here with solid phase extraction, with the advantage of enriching the analyte of interest. You've also got a great variety of materials which is available on the market where you can play around with chemical properties. On the other hand, it's more time consuming than other methods, and you've got this limited selectivity when compared, for instance, to immunoaffinity columns. Mycosep or also multi-sep columns, they are really the easiest on the market. I would say they are very rapid. However, no enrichment is achieved, especially with the mycosep columns, and they are less selective. Also compared to the immunoaffinity columns, which show the highest selectivity due to the specific antibody and the gene reaction. We have got an enrichment of the mycotoxin of interest, however, high costs and often only for single toxins on the market, but that is actually also gradually changing, but then again the costs rise. The question we have to ask ourselves nowadays, particularly in view of LC-MS technologies, is how selective actually has a cleanup really to be.